I will teach you how to solve Euclidean algorithm by Euclid. So we have the formula here. A is equals to BQ plus R, where A and B is given and Q is the quotient of A and B and R is the remainder. So this formula is used to solve the greatest common divisor. So this formula, we're going to talk about that later. So here's the problem. Using the Euclidean algorithm, solve for the GCD, or the greatest common divisor, of 878 and 252. So copy the formula here, and then substitute where A is given, which is 878, and B is given, which is 272. And remember, keep in mind that A is always greater than B. So we have 878 equals 272 times 3 plus 62. You might be wondering why we have this 3, because as I said, this 3 is equivalent to R, which is the quotient of A and B. So when you divide A, which is 878, and when you divide B, which is 272, you'll get the quotient of 3, and of course it has its remainder 62. So that's what happened here. Another is, we have another process. So we have the process here. After the substitution, the B will become A. So here, the B that will become A, and the R will become B. So that's what it happens here. So the 272, somewhat like transposing, then it becomes the letter A, and the R, which is the 62, it becomes the letter B. So same process again. 272, 62, find its quotient. It equals to 4. And it has its remainder again. So same process, 62, then 24, then find its quotient 2, then remainder 14. So 24, so the 24 becomes the letter A, so it transposes here. Then the 14 becomes letter B, and the quotient is 1, and the remainder is 10. Then same process. So 14 became A, then become B, and it has its remainder. Then 10 become A, then 4 become B, and it has its quotient, then remainder. And the 4 becomes A, and the 2 becomes B, and it has its quotient, then O. So it has its quotient. So it has its quotient, which is 2, and it has no remainder. So in finding the GCD, it is the remainder before the 0. So this is the GCD. It is the number before the 0.